Engineers, I have a problem. I have an amazing border collie, but she's a working dog. She likes to wake me up between 5 and 6 a.m. just to come say hi and get some pets. Usually I don't want to get up quite that early, and so I tend to go straight back to bed, but I have to get up and open my door. So I need to come up with a solution to open my door from my bed without getting out. In order to come up with a solution, I'm going to use the engineering design process. Are you ready to go on an adventure with me? This is an engineering design process. Typically, each company has a different process that they use, but here is a pretty standard one. The first step of the engineering design process is to define the problem. So in this case, the problem is that my dog wakes me up and I don't want to get out of bed. So here's the room. So I have to go from my bed to opening the door without leaving my bed. Let's see, what are our options? We have floor space, ceiling, and everything in between. How are we going to make this distance? So now that we have defined the problem and looked at our space, let's brainstorm solutions. So let's think about this. What are some solutions that we could have? Well, the first obvious one is to just leave the door open overnight. My dog can come in and out as she pleases, and I don't have to get up to open the door. What's some other solutions though? Well, we can make a giant grab arm that opens the door. That's a solution. What else? What about a pulley system? For those of you who don't know what a pulley is, it's basically a piece of metal that has a bearing on it that allows it to turn. These are especially useful for lifting heavy object or weight. Now, you might be thinking, how does this translate to opening a door? Well, if we create a system that goes from my bed to the ceiling, to the door, we could effectively use that motion and that weight to open the door. Now, it's not a lot of weight, just a door, and it's a very thin door at that, but we could use it to open the door. Next, let's research each of our ideas. So for option A, we just leave the door open. Well, let's think about why I closed my door in the first place. My mom likes to get up early and she likes to be able to turn on the lights in the morning. So that would mean I would probably be woken up often with my mom walking by or the lights being turned on and off. So that's not really a great solution for this. Let's look at option B, a giant grab arm. Okay, this is a better idea. It involves my door staying shut, being shut in the beginning at least, and I can do it from my bed if it's giant enough. So I think we should keep going with that idea. So let's put a little red on this one and a green check on this one. And the pulley system, let's think about that. Option C. Yeah, I could be in my bed, the door would already be shut, and then I would be able to open it. So that gets a green check mark for me. So our next option is create a criteria and constraints. We've kind of already covered this, but let's look at it again. So for the first one, it was the fact that door needs to start shut. Just that easy. For the second one, let's think about it. Do we have any constraints stopping us from using that? Well, for this project, my personal goal is not to spend any money. So I definitely could build a giant grab arm with just using my creativity and the stuff around my house. So that meets the criteria, meets the constraints. So I'm not seeing anything wrong with that. Now, if we look at that, what can we do to constrain that, to make it more reasonable? Because obviously I could make a giant, huge thing that way overdoes it, but does that solve our purpose in the most efficient way? Probably not. Let's see, how could we make this at home with just the stuff around us? It would be quite challenging. What about a different style grab arm? Using 2 sticks that you can push together. This requires a little more difficulty of use when I'm half asleep in my bed, right? I don't want to wake up all that much. Then it's hard to fall asleep. So let's add that to our criteria. I like that. That's a good criterion constraint. What about the pulley system? So this is very, very easy to go crazy with. Well, we want it to be easy to use and without thought, that's for sure. But with pulleys, we also have to consider that there are strings and the pulley has to be connected to something. So there's a lot of detail and weight has to be factored in as well as torque. So this might be a little complicated. So we'll put string and weight constraint. That looks good for the pulley system. It's now time to consider alternative solutions. So we already have 3 solutions, but let's see what else we can come up with. Let's think about it for a second. Think about the space and what we can do. Well, I mean, it doesn't really help us at all, but if we think bigger, think outside of the box, we could build a motor powered by a battery that opens the door to push up a button. That would be interesting. We could also build a crank powered by a smart plug that I could just tell Siri, "Hey Siri, shut my door please." I do have smart plugs available. That's an idea. Not really liking any of these ideas better than the previous, but it's always good to think what else we have. So before we select our approach, which is our next step, it is time to look at what we have available for us. First thing I found was some blue painter's tape, the nice wider variety. I also found some string or some rope. What else do we have? Well, we have this wooden stick with edges. Let's check out the toolbox. Let's see, some scissors. Oh, pulleys. So we got some pulleys. So selecting our approach is our next step. So looking at what we have, our rope, tape, pulleys, that wooden stick. Let's think about which those fit best. Well, the wooden stick is not long enough to make a grab arm with, or even something that could pull the door open. The pulley system. Well, we have pulleys, we have rope, we do have tape. Those all seem like things we could use for a pulley system. So I'm going to guess that the most logical way to go from here, besides just leaving the door open, which is not really a solution given our criteria and constraints, is to use the pulley system. So that's going to be our choice. So now we get to create our design proposal. This is my personal favorite part. So we're just going to start with a sketch. So here's a sketch of my room, just in general. Let's see. So if we have a pulley system, now the easiest way without any pulleys would just to have a string here and go all the way to the door. So when you pull the string, the door opens. Let's try that. This is going a little bit into building a prototype. However, the thing with the design process is you see these arrows? That means they go both ways. So if you get to a step, like building a prototype, and you realize, oof, this prototype, not going to work. Guess what? That's the great thing with this process. You can go right back to creating a design proposal. Just like that. It's that simple. I love this process so much because of that. It allows you to have total creative control. All right, so let's start with building a prototype. So to begin, we start with the string. Let's see. So we need the string to go from my bed here to the door. So let's start on the door side. Pretty simple so far. And then we have the string. So let's test it before we mount it. So we have the string tied to the door. Okay, so far so good. I like that. So this is a good moment to take a pause. Usually in my videos, I script out the entire thing basically from start beginning to in my head to make sure that I know what I'm doing and go with the purpose. In this video, I wanted to go through the process with you as we went. I didn't want to have an end result before I went through the process. So in this case, we ended up coming up with a solution that was not what I initially expected to. And guess what? That's what the process is supposed to do. It's supposed to lead you to the best solution, the most efficient solution, through thinking things through, brainstorming, developing a solution. So this is why I'm really excited to see this solution, because it's way simpler than I was even thinking. I was thinking we were going to have a pulley system with wires, but that's not necessary, and the system showed us that. So we're going to continue to go through the system, but this prototype is working really well. So let's finish the prototype now. So we have the string. We just need the tape. Tear off a little piece. Grab the string. Connect the door. Make sure that you measure it to be the right length. And give it a little bit of slack. And just tape that on right there. Now we can open the door easily. Just like that. Super easy. String's not going to fall off. Now we can just use the scissors. Cut the string, and that's our prototype. So I'm going to take a picture to document this in our engineering design process. It's always good to document your process. I highly recommend it, as we're doing right now with our table. So let's continue. So back at our table, our engineering design process table, we have some editing to do. So I'm going to change my color just to show that these are edits. I like orange. Let's go with orange. So we went to select approach, we selected the pulley system. We didn't end up actually using any pulleys. So when we created our design proposal, that was the string idea. That was the first basic idea that we had. And guess what? It seems to have worked when we built our prototype. So I'm just going to say straight string, no pulleys. When we built our prototype, that ended up being our design proposal, and we have that right here. That's our design proposal in this case. Usually they're a little more advanced, but for this, that was our sketch, our design proposal. And we built our prototype. So for building our prototype, I'm going to say see figure A. So when you use any kind of diagram, so like this actually should be figure A. This should be figure B. Anytime you use any diagram in your notebook or your engineering design notebook, anything, this is a notebook in this case, you should always document each figure. It's always a good idea to document your figures, because then you can refer to them later without any confusion. So we're going to make this figure C. So from there, this is going to be our figure C. And we can see we have our string. I realize you can't see that. We have our string here. And when we pull this, it transfers that force along the string, tightening the string, opening the door. Just like that. So it's even cool to write that out. It helps you in your mind know what's going on. So this is our observation, basically. Observations. This helps us know when we're evaluating, if we go back and make other design propositions or other prototypes, this helps us know to go back, see, okay, this is what worked with this, what didn't work with this. Force from pull, tighten string, in this way, just like that. Perfect. We just documented our observations and our design prototype. So now we can test and evaluate. With this, the best way to test and evaluate our prototype is just to open the door a bunch, see what we like, see how it goes after you've done it a bunch of times, that kind of thing, To speed this up, I'm going to do a time lapse of this. Oh, so we see our first issue right here. This knob on the door is catching our string, and it's causing the door not to close all the way. Now, if you can see right here, you'll see what I mean. So that's an issue, something that we need to address. So in our testing, we came up with a problem on test number 2. When pulling the string, if we just let the door close on its own and we don't necessarily guide the string down, this string tends to get caught. How can we solve this? Let's think. Well, if we lengthen the string, we're still going to have the same issue because when we pull this, it's going to be too tight, right? Because when you're now adding some friction, it increases the force. So what else can we do? We could use a pulley, but I'm convinced we don't need to use a pulley for this system now that we've seen how simple it can be. What else can we do? What about running the cable behind the dresser so we don't have to deal with these knobs on the front? I like that idea. Let's try it. Alright, so let's cut the string, retie it. It's ready to rock. Alright, so running behind. We did it! So we created a second design proposal, which we did after we tested and evaluated and found that we had a problem with our prototype. So let's document our problem first. So I'm going to write it in red. So that's our issue. We're going to give it a big red X. So now let's go back for our creating our design proposal. Let's create a new proposal. So this proposal actually stays the same. When we build our prototype, we now want to see figure D. And figure D is going to be our new design. And you can see it goes behind now, and it ends up there. Now there is a little bit of friction, so we should note that. And if you know, friction is a force. So that does cause slight issues, but it's not a deal breaker in this case. Slight friction. However, if you were doing a proposal for a company, that might be a deal breaker for them. So you should always come up with multiple solutions. Slight friction, not deal breaker. It's always good to make notes. And so we've documented exactly how it works, and it looks great. So that is there. Now our testing. So we just tested it. It works great. There's no change in performance, but we no longer have to worry about the knobs, which is exactly what we wanted. So we did a great job with that. So let's continue. Testing's done. Testing went great. Observations. So we can note that slight friction. This is definitely a serious thing to consider, especially for a consumer product. But we don't have to worry about this because string is cheap and we have a bunch of it. If it breaks, I can fix it. Alright, what else did we observe? Well, we observed motion was slightly changed because of that, but it's not a huge issue. We should note it though. See how I can reference figure C? That's why you always want to label your pictures as I said that. I realized I didn't label this figure D. Oops. So we have that. Everything looks good. We wrote our observations down. So now we can move on to the next stage, which is refine. It passed, by the way. So we did basically refine when we looked at our last one. That was what process we ended on, and then we had to go back from refining to creating a proposal. So we did that already. Then we went back to that and back to that. So now we're back at refining it. We looked at it. It looks great. We can go on to creating our solution. So this is basically putting it all together and presenting our results. These two are very tied together. Well, we've basically presented it, but if we want to do it a little nicer, we can go back to this, showing that this was our original design. Oh, I just realized our diagram shows the old design, so we can fix that very easily. So motion pulling that way will result in this being pulled. Actually, sorry, that arrow should be this way. So when you pull this way, the result is the red arrow. So I'm going to write that out. And you should always have a final statement that says what your product does. So in this case, product allows you to open door from a distance. And bam, that's our proposal. So we have our diagram, we have our final result. Our prototype in this case ended up being our final result. It isn't always. And we have our explanation. So obviously if this was a very professional proposal, there would be a lot more details. But in this case, this is exactly what we're looking for a homemade, just your own reference kind of notes. So this was so fun to go through with you guys. I learned a lot about the process and how it helped me. We've ended up here. And so I hope you all had a great time going through this. So what about you? We just went through this whole engineering design process to help something that improves my life. And I am thrilled. This is going to help me every day. What about your life? Is there anything that you know in your life, or look around your routine and see what could make this easier? What could make this better, more efficient? And then use the process. Document it just like we did through the process. And you never know what you'll come up with. Using your creativity, innovation, imagination, all are things that successful engineers use. So when you use them, even for something little like using a string to open a door, going through the process, those strengthen those skills and help you become a better engineer in the future. So I hope you really enjoyed learning the process, going through it, and I hope you have a wonderful day.